Right, let's rip into question 2. For this question, let's use the ACC method. Assume, calculate, cancel. Because we've got a 3 here, I'm going to assume it's 3x divided by 3. And then I'm going to list the factors of 3 times 32, 96. The signs are plus or minus, and the factors of 96 that have a difference of 20 are 4 and 24. And we can see that 3 fits nicely into the first bracket and cancels it out. Easy. When squaring this, make sure you square the number, and same for the bottom. So I'm going to expand it out first, remembering for powers of powers multiply, so the 2 times negative 3 makes negative 6. Now deal with your numbers. 36 over 16, simplify that. And we know we subtract our powers, so negative 6 minus 4 is negative 10. And you'll all know that a negative power becomes positive when you put it downstairs. And that was less painful than going to the dentist. Well, here's a tricky little one. So let's factorize the top line on the left by x squared. And if you could recognize that this bottom one here, the denominator, is the difference of 2 squares, so you factorize that. And in case you've forgotten, there's my working. Now we can't do much with the 5 at the top, but we can factorize the bottom in the next one. Can you see that the x plus 4 cancels out there? Now when we subtract fractions, we need a common denominator. So I need to make this x minus 4 x minus 4. Well, how do you do that, I hear you ask? Well, you make x minus 4 on the top and x minus 4 on the bottom. And what I've put in red there is equal to 1, so we haven't changed the value. So I've just adjusted the left one a little bit to make it equal, so the denominators are equal. Now tidy up your numerators. I'm going to write the answer up here. We can see it's x minus 4 all squared for the denominator, and that's for the numerator. Now you wouldn't do anything silly like trying to cross one of these x minus 4s with an x minus 4 there, because this minus 5 is a barrier to that. So let's not be silly today and leave our answer correct like that. Well, to get started in this question, you have to know that the discriminant equals 0. So we've got to make b squared minus 4ac equals 0. That will mean it will touch in exactly one place. Then what is b in this question? It's negative 6k. What is a? It is 3k plus 2. And c is the plus 4. Substitute it in and solve it. Easy. There's our first line, just substituting in for a, b and c. Now simplify. I decided to multiply those two together first. You could have expanded the brackets first. You'll still get the same answer. And I'm tired. It's late at night. I should be asleep. I forgot it was negative 6k all squared. Now that's a nasty little one that won't factorize easily, so I used my calculator equation solver. And there are the answers to 3 decimal places. This question looks really nasty, but if you get down to here, it just tells you to solve this equation. So let's do that first. So first of all, I put everything on the left hand side, and then I can factorize it, or use your solver equation on the calculator, or quadratic formula. And we can see that n equals 15 or negative 11. We're not going to have a negative row, so it's just the 15th row. So what is this question asking us? It's asking us where the sum of the numbers is the same as multiplying by 65. Well, here's the sum of the numbers, and there's the row number. So let's get to it. The simplest way to do this is divide both sides by n, and it cancels out. Then shift the 1 to the other side. And the square root of 64 is 8. Woohoo! So what is this asking? It's asking the last number is 3 times the first number. So let's have a look at the last number and the first number. Those are the two equations we want. Well, that shows the last number on the left is 3 times the first number on the right. expand the brackets. Move everything over to the right hand side, then you won't have any negative n squared. Now the question hinted this might not be possible, so b squared minus 4ac might be less than 0, that means it's not possible. So let's check it. So substitute a, b and c into the equation. And we can see that negative 36 is less than 0, so therefore there are no solutions. Another excellence question finished.